Welcome back, friend. Tonight, we are going to drift together along the dim, unhurried frontier people like to call the edge of the universe, and then meander quietly beyond that phrase into the ordinary and the almost forgotten details that make the cosmos feel cozy and surprisingly familiar. Imagine yourself settling into a comfortable position, your shoulders soft, your breath slow and even, as if each inhale were a tide that arrives, and each exhale were a tide that retreats. We will let numbers and distances pass by like clouds, and we will let the gentle rhythm continue without any need to keep up. If you enjoy resting to these soft explorations, please like and subscribe. And if you want an easy way to stay lulled by science, there is a playlist link in the description to keep learning while drifting off. What made you click? Title, thumbnail, or topic? Imagine yourself standing on a quiet, dark plateau with nothing but open air and a soft, cool breeze across your face. The sky above is the calm ceiling of the night. It is sprinkled with points of light that look close enough to breathe in and far enough to be timeless. There is no hurry here. There are no alarms. The edge we speak of is not a cliff, not a line, not a boundary with any sharpness at all. It is a horizon of understanding, a smooth shore where light has had just enough time to reach us. You tip your head back, and the dome of the sky feels like a bowl of still water turned over and set upon the world. You can almost hear the silence, a soft tone that is both infinite and intimate, like the hum of a sleeping house. The idea of an edge tempts the mind to picture borders or walls, but the universe prefers to be gentle and gradual. If you were to travel outward, beyond the familiar stars, beyond the known catalogs and the comfortable maps, you would not find a fence. Instead, you would find thinning threads of light, stretched by the universe's steady expansion, the way a whispered word dissolves as it travels down a quiet hallway. The visible part is what can be seen, because light and time have agreed to meet us here. The rest is not forbidden, only farther than the story of light can yet tell. You find yourself at ease with this, as if listening to a long novel being read in a soft voice, knowing the end is not needed for the moment to feel complete. In the far background, there is a faint glow, not bright, not demanding, simply present, like the afterheat of a day stored in a stone. This is the old light of the cosmic microwave background, the leftover warmth from when the universe was a warm mist that finally became transparent. If you imagine steam on a window settling into clarity, you have the feeling. That light washes over everything equally, arriving from all directions with a nearly perfect sameness. The gentle rhythm continues, and the patterns in that sameness are subtle, like the slight differences in the weave of a blanket. Those differences are the seeds of structure, the quiet beginnings of every galaxy and cluster you have ever seen in a picture. If you walked along this edge, though walking is just a thought experiment for a mind at rest, you would notice that distances behave like elastic tape, stretching as you go. So the further you think you have traveled, the more the scale has lengthened under your feet. It is a comforting paradox, because it means there is no pressure to arrive. You can let your attention drift, and the universe expands gently around that drift, like a soft blanket being carefully unfolded. Within this unfolding, light changes, sliding toward deeper reds, as if it were a sound sliding toward a lower note. Stars, you cannot name, whisper their records. The glow that was blue becomes a muted ember. You do not have to remember the numbers. You can simply feel the calm of the trend, a steady shift downward, a mellowing of color and pitch. Some nights, astronomers who measure these shifts sit in rooms with quiet fans and softly glowing monitors. The hum of their equipment is a companion, and their notebooks fill with the language of patient work. There is comfort in those details. Lamps with warm bulbs. A mug that has cooled enough to forget. The gentle click of a keyboard. Outside, domes move so slowly you can barely tell, and mirrors reach for starlight with the delicacy of a hand dipping into a stream. Imagine yourself there too, hands resting, breathing slow, while the telescope takes in light that began its journey when no human eyes existed to look back. In this domain, units are lullabies. A meter is not a law. It is a reassurance, an agreed step. A second is not an alarm. It is a soft beat, a heartbeat of time itself. Astronomers talk about arcseconds and parsecs in voices that could read bedtime stories. An arcsecond is a tiny slice of the sky, and a parsec is a distance woven from that tiny slice, and the geometry of a triangle so large it feels like a gentle joke. The gentle rhythm continues. Angles make distances. Distances make stories. And stories make the universe feel close enough to touch. It helps to picture the cosmic distance ladder as an old staircase in a quiet library. Each step is broad and shallow, easy to stand upon without fear of a stumble. On the first steps, you have parallax, the shift in a star's position as Earth moves through its yearly path. You can imagine looking past your thumb, then switching eyes, and watching the thumb move. The stars do this too, very slightly, very calmly, and from that calm shift, distances can be slowly measured. Further up the staircase are familiar lanterns, Cepheid variables, stars that brighten and dim with reliable rhythms, like breathing. Their pulse becomes a yardstick. Farther still are supernovae, but even those can be considered in a gentle way. The peak of their light is a marker, a steady flicker noticed and recorded, not a bang, but a beacon. Step by step, all the way to the faint edges, where galaxies are little smudges, the ladder holds. It does not rush you. It does not creak. It simply waits for you to rest a foot, then another, then pause. When astronomers observe, they carry out rituals that are as soothing as a nightly routine. Before the real exposures, they take a bias frame, which is a picture with no light, a zeroed sigh. They take a dark frame, the same, but longer, letting the camera show its own gentle static. Then they take flat fields, softly illuminated images that reveal the way the telescope sees the world. Small brightness variations, tiny dust shadows. Imagine it as smoothing a sheet over a bed, pressing out wrinkles with a careful hand. Then the real images come, one after the other, a sequence of captured light, arriving from a time beyond any clock you know, stitched together into a neat file, tucked into a directory labeled with the date, the filter, the target, the calm, predictable details that let later eyes find their place without any strain. Filters themselves are like colored glass in a nursery window, each choosing a section of light to let through. You may hear the vowels of their names, soft and short. U, G, R, I, Z, each one a layer, stacking to create a picture that is fuller than any single shade could give. There are broader filters and narrower ones, and there are slices of the spectrum that correspond to lines produced by simple atoms. Hydrogen, with its characteristic whisper of a color, shows up in those slices, and helium, and oxygen, and sulfur. These are not dramatic fireworks. They are the careful fingerprints of clouds and stars, showing their quiet chemistry without raising their voice. Beyond chemistry, there are motions. Galaxies rotate, not hurriedly, but with the patience of a slow dance that began before anyone could watch. We infer their motions from the way spectral lines slide to one side. The shift is small, precise, a movement measured by calm algorithms that compare one pattern to another, as if aligning spines of books on a shelf. These algorithms are written by people who know the comfort of a clean desk and a gentle cup of tea at midnight. Their screens filled with rows of numbers that line up obediently. The gentle rhythm continues. Read, compare, adjust, save. You can imagine the data pipelines as rivers that flow without rapids. Raw images glide into calibration, then into astrometric solutions that match the stars' positions to a quiet sky map. Each star is given coordinates, right ascension, and declination, like an address in an old town where every street is drawn on a parchment map. There is also local sidereal time, the kind of time that obeys the sky's rotation, a clock that is not in a hurry to match the habits of cities. Observers check the hour angle, a little phrase that sounds like a secret, to know how far past the meridian a star has drifted. None of it asks for agitation, none of it asks for speed. It is all very familiar, very generous, very patient. Imagine now the observatories themselves. A radio dish sits at the edge of a quiet desert, where the air smells faintly of dust and dry sage. The dish slowly tips up, then down, then sideways, scanning a patch of sky with a gentle, repetitive sway. Every motion is smooth by design, to keep vibrations low and minds at ease. Inside, the equipment hums like a warm refrigerator, steady and barely there. In the corner, a small red light indicates that recording is in progress. On the monitors, the readouts increase in neat columns, numbers filling their places like sand, settling into the bottom of a clear bottle. Somewhere far away, a satellite at a stable point in space spins and nods, scanning the entire sky with the diligence of a lighthouse, mapping faint microwaves with a beam shaped like a softly blurred circle. The scanning law is a pattern chosen for evenness, so every part of the sky sees the same attention. Symmetry is calming. Fairness is calming. The map that results looks like a smooth oval, a sort of flattened sphere, where the faint differences are painted in blues and reds that never shout. All of this is connected to the idea of a horizon, which in quiet terms is simply the limit of what can be known through light, right now. It is the boundary of a story told at a certain speed. The story will lengthen, because time does that, and the light from farther places will arrive eventually, though the expansion of space will keep some places always out of reach. This is not tragic. It is simply the geometry of a calm ocean that is stretching slowly. You rest into that idea, as if placing a head on a pillow that is neither too soft nor too firm. Let us wander to galaxies. The nearby ones are familiar neighbors with names that sound like older houses on a street. Andromeda, Triangulum, the large Magellanic Cloud. Each has catalog numbers as well, tidy and comforting, as if filed in a drawer. A galaxy can be a spiral, which means a disk with arms that curl like the tops of ferns. Or it can be an elliptical, smooth and featureless, like a softly glowing ember. Some are irregular, which is a way of saying that not everything needs to be sorted. Within them, stars form in clusters that look misty and cold in long exposures, and dust lanes thread like silk through their centers. Even massive clusters of galaxies arrange themselves patiently, bound by gravity's gentle tug, and between them lie wide spaces called voids, not empty, but quiet, with very few galaxies to disturb their hush. These large-scale patterns, when viewed on a very big scale, look like foam on the surface of hot milk that has cooled, each cell a region of galaxy clusters with soft edges. The shape is not exact, but the feeling is. You can imagine the universe as a net with wide squares, where galaxies collect along the threads, and the squares themselves are sparsely populated. The net sways slowly, not because anything is shaking it, but because it is alive with the slow growth of structures over unimaginable time. The gentle rhythm continues. Gravity gathers, expansion stretches, and between these two tendencies, a balanced dance plays out without drama. Closer to our small home, the details continue to soothe. The solar system is a predictable carousel. Planets move in quiet ellipses, some slightly tilted relative to others, but none in a hurry to change the pattern you learned once and can remember without stress. The Earth turns, and this rotation makes the sky appear to turn in the other direction. It gives us the idea of the hour angle and of sidereal time, which is simply the universe's way of keeping its own calm schedule. Astronomers plan their nights by these times, marking when a target will be highest and most steady, as if choosing the best moment to pour water into a cup, when the hand is most stable. The instruments used to capture light are themselves small worlds of quiet design. Detectors collect photons one by one, and each one is a little tap on the shoulder, a tiny suggestion that something, somewhere, simply existed and sent a whisper. Over the course of a long exposure, millions of these taps accumulate, and what was invisible becomes a faint, dignified shape. Calibration ensures that the shape is true, not distorted by the equipment's character. It is as if you were cleaning a window not to change the world, but to let the world in as it is. At times, The edge of the universe is thought of as a surface of last scattering, the final fog clearing in an early era. The words sound technical, but the image can be cozy. Picture a room filled with steam that gradually thins until silhouettes resolve into people and furniture. No sudden change, just the gradual lifting of a veil. The light that left at that moment in cosmic time has been traveling ever since, and as space itself has stretched, the wavelength of that light has stretched with it, becoming longer, softer, transforming from bright into gentle. Now it bathes the universe in a faint, microwave glow that is nearly uniform, with tiny variations that tell a story, written in small letters. The people who read that story use spherical harmonics and power spectra, terms that feel like waves and symphonies, more than equations when said in a slow voice. They produce maps and charts with low, uncluttered colors, and they interpret those with care. Their conclusions are not banners. They are cushions, small, well-placed supports that hold the model of the universe steady. As you listen, you are not asked to carry anything heavy. You are invited to let the ideas keep you company, like a cat settling quietly at the foot of a bed. In the farther reaches, where galaxies are seen as they were billions of years ago, their light is faint and stretched. Observers stack images to bring out details. Stacking means layering multiple exposures, aligning them so the stars overlap perfectly, and then letting the real signal rise above the background. It is not dramatic, yet it is powerful in its quiet way. Noise fades, as if it were a bustling day, receding into a calm evening. The sky grows clear, the shapes become more certain, the gentle rhythm continues. There is a different kind of edge, too, the one that appears when gravity bends light. Gravitational lenses act like glass lenses, curving the paths of photons so that a background galaxy can appear as an arc around a foreground cluster. These arcs are delicate. They trace out potential wells and caustics, words that in other contexts might sound sharp. But here are simply the outlines of how gravity guides light. Analysts reconstruct the mass distribution that must have caused the arcs, like a person piecing together the reflection of a room from the shape on a spoon. The mathematics is careful and measured. The results are maps with contour lines that increase in value like a very slow song, increasing in volume by barely noticeable steps. When stars are born, they do so in the quiet privacy of molecular clouds, wrapped in dust and gas that absorb harsh light and re-emit at longer wavelengths, as if passing a message through several layers of cloth. The grains of dust are small, about the size that is comfortable to imagine on the skin of your hand, and they are often made of silicates and carbon compounds, familiar friends in chemistry. They can align subtly in magnetic fields, and that alignment can polarize the light that passes through, giving astronomers a way to infer the invisible structure of those fields. The measurements are gentle. Polarization angles are recorded in degrees that circle smoothly. No jagged edges, just a direction that is more likely than another. In the everyday practice of astronomy, there are catalog entries that read like lines of poetry in their quiet consistency. Coordinates, magnitudes in several filters, an estimate of distance, a redshift with an uncertainty, a flag for quality that might simply be a number from 0 to 1. Pipelines propagate these values from one table to the next, and researchers write scripts with names like reduce.py or fitlightcurve.sh. The logs they produce are polite and chronological. Start time, input files found, processing step complete, results saved. You can imagine these lines printing slowly in a terminal window, each one a tick in a clock that has no urgency. There is a guide star that tells a telescope how to keep itself steady. The telescope watches it constantly, making micro-adjustments with a mechanism called a tip-tilt mirror, which is just what it sounds like. Tiny movements that keep the image sharp. The corrections happen many times per second, but the result is not frantic. It is serene, like a person making small, invisible changes in posture to stay balanced without rocking the chair. Meanwhile, an atomic clock in a rack nearby keeps time with a calm authority. Its oscillations are so regular that time zones and calendars take a back seat to its quiet pulse. Even leap seconds, inserted now and then to reconcile Earth's rotation with modern timekeeping, arrive like soft footfalls on a thick carpet. Light curves tell stories in lines that move up and down with the steady patience of tides. A star with a planet will dim slightly when the planet crosses its face. The dimming is small and repeatable, and beautiful in its restraint. Analysts fit these curves with models that have a few parameters: how deep the dip is, how long it lasts, how often it repeats. Each parameter is a calm piece of information, a leaf placed on a table. From those leaves, a tree is inferred, a family of objects. Names are assigned. Papers are written with careful prose that praises the instrument team, acknowledges the calibrations, and states the results in plain tones. Instruments in space operate at the Lagrange points, such as L2, a place where the pull of the Earth and the Sun balance in a way that lets a satellite enjoy a stable, gently looping path. From there, telescopes look outward without the interruption of day and night, and sunshields spread like quiet sails to keep instruments in deep shade. The temperatures are kept cold, not bitingly, but precisely, because the sensors like to be calmed. Radiators glow softly in the infrared, releasing heat into space like a building that breathes out on a winter evening. On board, there are wheels that store angular momentum, and thrusters that make delicate adjustments, and all of it is scheduled in routines that run like lullabies. Astronomers also live by proposals and observation plans. They write with the voice of someone who knows bedtime stories are about setting the scene carefully. They describe the target, the filters, the exposure times, the need for scheduling at certain angles to avoid scattered light. They mention safe modes and contingencies with no drama at all, just a quiet preparedness. When the time comes, the observation is executed, and the data arrives in a directory on a server. The first glance is always cautious, a peek through fingers. Then the analysis begins, as gently as stirring tea. You find yourself noticing that even the units of astronomical flux sound like they belong to a night of calm reading. The Jansky is a very small unit, and because it is small, it lets numbers stay modest and unassuming. Magnitudes invert the logic of brightness in a way that could be annoying, but here feels like a playful puzzle that never needs to be solved. Lower numbers are brighter, higher numbers are dimmer, and differences of a few magnitudes correspond to comfortable ratios. The AB magnitude system is a choice that makes certain calculations easy, and though it could lead to formulas, you are not asked to handle them now. You are only asked to accept that there is a consistent system and that others will take care of the algebra while you rest. The edge of the universe can be talked about in another way, through the light cone, a diagram that shows what events can be connected by light. Imagine a slow, expanding cone of possibility. The surface of the cone is where light travels. Inside is where influence can reach. And outside is where events are still out of touch. This is not a prison. It is a map that shows what parts of the story are written in the current chapter. The later chapters are there, but the pages have not been turned yet. The gentle rhythm continues, and you are content to stay in the current chapter. One of the quiet pleasures of astronomy is learning the geography of the sky. Constellations are cultural and change with tradition, but they also offer a framework for finding your way. Like neighborhoods in a city you visit at dusk. Right ascension corresponds to time, declination to latitude on the celestial sphere. The North Star sits very near the axis of rotation, and it gives a sense of stability, even though it too moves slowly over centuries. Star maps show grids that curve, reminding you that the sky is a dome and not a flat sheet. You can point to a region and know that many catalogs overlap there, each offering a different view, like layers of tracing paper. As the night deepens, the air can feel a little colder, and your mind drifts further. You think of calibration lamps that glow gently in instrument rooms, filled with gases that produce specific lines that are used to align wavelengths. Neon, argon. A soft spectrum appears on a small monitor, lines at known positions. Reassurance distilled into light. Technicians note that the lines are where they should be, and if they have shifted, a dial is turned a small fraction to put them back. The care is intimate, nearly domestic, like straightening a picture frame on a wall. The edge we describe is also present in the concept of the event horizon of a black hole, though here we will keep our distance and speak only in quiet metaphors. The event horizon is a surface of no return, a place where light that falls inwards cannot turn back outward. It is a one-way fence made of geometry, not metal. For us, far away, the edge is a silhouette, and time there seems to slow if we could watch it. The object is not a monster, but a very tidy region where gravity's rules become strict. Around it, hot disks can form, and jets can emerge, but we will not follow the heat or the speed. We will just note that even in the presence of such extremes, the shapes are elegant and the math is composed. Closer to home, the moon moves through its phases with a predictability that could lull a child. The line between light and dark on its surface, the terminator, moves across craters and mountains, revealing and hiding with a slow, steady hand. Observers can time occultations, moments when the moon passes in front of a star, and these timings improve our understanding of orbits and places. The numbers are recorded with timestamps from GPS receivers that blink a small, quiet dot on their screens. The accuracy is a comfort. like a ruler that always measures the same length every day. The Earth's atmosphere itself is a participant in all ground-based observing. And though it seems like an obstacle sometimes, it is also a friend. Its turbulence makes stars twinkle, and while that twinkle is a blur for sharp images, it is also a reminder of a living sky. Adaptive optic systems tame the twinkle by measuring it and adjusting mirrors many times per second, flattening the wavefronts so that the image sharpens. The correction is dynamic, but also rhythmic, a closed loop that simply keeps forming solutions. The wavefront sensor sees patterns of spots that shift slightly, and those shifts are turned into actuator commands. The loop hums on, steady as a soft metronome. In radio astronomy, the wavelength is long, and arrays of dishes spread across deserts or valleys act together to synthesize a larger aperture. Signals are recorded with precise timing and combined later, a process called correlation. This requires knowing the delay between when a wavefront arrives at one dish and when it reaches another, a delay that depends on geometry and even tectonic drift. The corrections are computed and applied, and the fringes align, and an image emerges from the mathematics like a gradual shoreline on a foggy morning. It is patient work, and it rewards patience. There is a textbook patience, too, in cosmological simulations, where computers let gravity and simple fluids evolve in digital universes. The initial conditions are small variations, and the rules are statements of how matter moves and attracts. Over time, the simulated universe develops structures that resemble the ones we see. Filaments appear, voids open, clusters gather. Analysts pause the simulation at intervals, storing snapshots, then comparing them to surveys that sweep the sky. It is like looking at family photo albums and noticing the resemblance between generations. The gentle rhythm continues. Sometimes, people ask how we know the age of the universe, and the answer is a collection of quiet cross-checks. The expansion rate, measured through redshifts and distances, sets a scale. The cosmic microwave background gives a pattern that depends on the composition and the expansion history. The ages of the oldest star clusters set a lower bound. All of these whisper to each other, and the whispers align into a consensus. Numbers are reported with uncertainties that are not weaknesses, but honest cushions surrounding the truth. Error bars are softness built into our statements, acknowledging that measurement is always a conversation, never a decree. If you listen closely, you can hear how frequently astronomers say the word map. There are maps of stars, of galaxies, of dust, of gas, of dark matter inferred from lensing, of velocities, of temperatures, of polarization. A map is an act of kindness. It gives you a way to stand somewhere and point and say here and there. Maps can be layered, compared, subtracted, and smoothed. Smoothing is another lullaby word. It means reducing the sharpness so that broader structures appear. The smoothing scale is chosen with care, not to erase reality, but to find the level at which the story is easiest to tell. You may be drifting already, floating in and out as the words flow. Still awake? Comment the secret word, nebula. Let us wander to the practicalities of a night's observing. The schedule begins on the afternoon before, with a list of targets sorted by when they rise and set, like a dinner plan arranged by the order of dishes. Calibration frames are taken at twilight, when the sky is bright enough to act as a uniform source. Focus sequences are run, which means moving the camera slightly in and out to find the crispest setting, a process that could have been written into a cooking recipe. Temperature sensors report their readings in quiet numbers that do not change quickly, and dew heaters are set to low values to keep optics from fogging. Cables are draped to avoid snags. A notebook lies open with a pen resting on its spiral, pages already filled with neat lines of times and notes. When darkness arrives, the first science target is acquired, which means pointing the telescope and making a small exposure to confirm the field. The exposure is not long. It is a soft glance. The guide star is found. The main exposure begins. During the long integrations, observers sometimes walk slowly to keep warm, and sometimes they sit and listen to the night. The night has small sounds, the almost inaudible whisper of motors, the hush of air moving through vents, the distant call of an owl, the quiet steps of someone in felt-soled shoes. In the control room, the displays show progress, a percentage creeping up. There is a ritual in waiting. You do not need to be present for each second. You only need to be available when the exposure finishes and the next begins. It is like knitting slowly, one row at a time, knowing that the blanket will eventually be large and warm. Back in the data, there are coordinate transformations that take you from the detector's pixel grid to the celestial sphere. These transformations are defined by coefficients that are stored in headers, small lines of text paired with numbers. The headers are like the table of contents in a book, and they contain everything necessary to navigate the pages. Tools read these lines and apply the formulas quietly. Later, when the images are mosaicked into larger maps, edges are blended with feathering so that the transitions are gentle, like watercolor washes meeting. The sky itself offers quiet patterns. Meteor showers arrive at predictable times of the year, and when you know they are coming, you can look up and wait without expectation. Some streaks arrive, some do not. Either way, the waiting is part of the joy. Zodiacal light glows in a soft wedge near the horizon before sunrise or after sunset, caused by sunlight scattering off fine dust in the plane of the solar system. Airglow gently illuminates the sky with the faint greens and reds produced by atoms and molecules in the upper atmosphere. Auroras, when they arrive, can be lively, but even they have moments of slow, rippling curtains that wave in long periods, like the breath of the earth itself. Calendars in astronomy include eclipses and transits, alignments that repeat with cycles that can be written down centuries in advance. The Saros cycle links eclipses like beads on a string, and ephemerides list the positions of planets, asteroids, and comets for any date you choose. Catalogs of minor planets are updated steadily, with each object receiving a designation that follows a respectful pattern. The names are not flashy. They are content to be identifiers, allowing us to follow objects without confusion. The gentle rhythm continues. Spectrographs spread light so that each color, each wavelength, is recorded separately. This is like listening to a chord and hearing each note. Lines appear at wavelengths that match transitions in atoms and molecules, and their shapes reveal temperatures and pressures. Absorption lines tell of cooler material in front of a source. Emission lines tell of hot, excited gas. The widths of lines can indicate turbulence or rotation. Velocities shift the lines by small amounts. All of this is learned by looking at hills and valleys drawn by the spectrograph, and the eye becomes good at reading these landscapes. They are not jagged, they are rolling and collectible. In some observations, time is the axis. Pulsars emit beams like lighthouses, and their regular pulses can be timed to extraordinary precision. The arrival times are corrected for the motion of Earth around the Sun, for the rotation of Earth, for delays in the interstellar medium. Each correction is a small courtesy to the truth, and the result is a signal that is so regular it can act as a clock. Arrays of pulsars form a kind of galactic scale detector for ripples in space-time that stretch and compress the distance between Earth and the pulsars in a slow, quiet way. The measurements take years, and the patience is part of the instrument. When we survey the sky, we draw boundaries on maps to define fields and tiles, and assign them to nights based on weather forecasts and moon phases. Seeing conditions are noted as full width at half maximum, a phrase that is easy to understand through feel. It is the width of a star's profile halfway up its peak. Smaller widths are sharper images. Transparency is assessed by comparing star brightnesses to standard values. If clouds pass, sensitivity drops, and the log notes a thin cirrus layer, like a veil. The observations continue, or pause, based on these readings, and decisions are made with a calm hand. Even the coding that glues everything together is written in a style that favors clarity over cleverness. Functions are named plainly. Variables have long names that say exactly what they hold. Comments explain what is happening and why, as if speaking to a friend late at night. Version control systems keep track of changes, and commit messages record the reasoning. Bugs are found with logs that tell the story of a process step by step. There is satisfaction in reading a log that ends with success after a balanced sequence of attempts. There is also satisfaction in a log that ends with a pause and a note to retry tomorrow, because not everything must be solved tonight. In the archives, data is stored redundantly, copies in different locations, tapes and discs, with checksums that verify integrity. The ritual of verification runs regularly, like the quiet cycle of a washing machine, and alerts are sent if anything is out of place. A librarian of the sky ensures that what is known will not be lost. Researchers can request data from years ago, and it arrives with the same careful headers, the same consistent formats. This continuity is a comfort, reminding us that knowledge is not only discovery, but also caretaking. Sometimes, the edge we consider is the limit of resolution, the smallest details an instrument can see. There is a soft threshold where structures blur together, and to go beyond it, we build larger mirrors, combine signals from multiple telescopes, or move instruments above the atmosphere. Each approach is a way of focusing gently, of bringing features into clearer view without forcing them. Interferometers stitch together phases of light to create images with astonishing clarity. But the stitching is mathematical and careful, like quilting, done by experts who work quietly in a bright room filled with the sound of low conversation. There is something soothing about standard stars. These are stars used as references because their brightnesses are stable and well measured. Observers point at them to calibrate their instruments, to ensure that when they say a galaxy has a certain magnitude, they mean the same thing as someone else across the world. Standards are trust made visible. They are the friends you call to check that you still remember the recipe correctly. They anchor the system. You might think of the sun as ordinary, and in many ways that is a kindness. It is a G-type star with a quiet kind of activity. It has cycles. It hums with oscillations that helioseismology measures, revealing layers and flows inside that we cannot see. The granulation on its surface is a bubbling pattern that looks like boiling, but the time scales are long enough, and the image is steady enough that the sensation is more like watching a slow simmer. Even sunspots, when they appear, are just dark patches that come and go according to the sun's own rhythm. Drifting further, you can visit, in your mind, the interstellar medium, so low in density that a vacuum chamber on Earth would seem crowded by comparison. The gas there is made of hydrogen mostly, with helium and traces of heavier elements. Dust is a small fraction by mass, but influential in how it scatters and absorbs light. Clouds condense where pressures and flows allow, and shocks pass through them like a breeze that gently folds the hem of a curtain. Magnetic fields thread through space, guiding charged particles in slow spirals, invisible lines that can be traced by the starlight they subtly influence. When people speak of dark matter and dark energy, they often pick heavy words, but you can hold them lightly. Dark matter is the name given to an unseen component whose gravity is real. We weigh it by the motions of stars and galaxies, and by the way it bends light. It is not an accusation. It is an invitation to acknowledge that not all partners dance in the visible. Dark energy is a term for the acceleration in the expansion of the universe, a gentle speeding up that we infer from distances and redshifts of supernovae and other probes. Together, these components tell us that what we are comfortable calling ordinary matter is a minority. This does not diminish us. It makes the tapestry richer. At the sensible scale of everyday life, measurement is an act of love. The kilogram is now defined in terms of physical constants, and the meter is tied to the speed of light. The second is defined by the transition frequency of cesium atoms. These definitions are chosen to be steady, so that the world does not slip under our feet. In astronomy, these constants translate into calculations that convert a redshift into a distance estimate, a flux into a luminosity, an angle into a size. There is a brief moment of arithmetic, then a restful report. This galaxy is this far, this bright, this big. The gentle rhythm continues. The catalogs themselves are sleepy novels. Gaia's release lists stars and their positions, motions, and parallax values with uncertainties that make you feel safe. Sloan's surveys offer spectra and photometry in bands that you can pronounce softly. 2 mass gives near-infrared light, comforting red and deeper. Wise maps the sky in mid-infrared, a little warmer, a little dustier. Planck and Kobe measured the microwave background so carefully that their names sound like friends rather than instruments. Each table row is a character in the story. Each column is a trait. You can read 1 billion rows and still feel that every one of them sits quietly on a shelf, available whenever you need company. As you drift, you might imagine the sounds that instruments would make if their signals were audible. The cosmic microwave background would be a soft hiss, uniform with slight, low harmonics. A pulsar might be a metronome. Tick, tick, tick. A quasar could be a long, sustained tone with subtle warbles. These sounds are not present in space as we hear them. They are metaphors that let your mind rest on something concrete. You could hum along, very softly, and let your breath match the rhythm. Looking forward gently, new instruments will come online and add layers to the maps. Surveys will be deeper and wider, covering more sky with finer detail. The cadence of observations will create movies of the heavens, capturing changes that have always been present but rarely seen. Transient events will be catalogued not as surprises, but as regular entries in calendars that update in real time. Software will help sort them, trained to notice patterns without needing to be told each time. This does not replace wonder. It simply reduces the strain on attention. Even the idea of a multiverse can be held in a quiet hand. It is a hypothesis in some models, a way of thinking that suggests other regions with different parameters could exist beyond what we can see. We do not have evidence we can touch, and that is all right. It is a bedtime thought that need not be resolved to be soothing. The sky we have is plenty, and the stories we tell within our horizon are rich enough for many nights. On a more domestic note, consider the way astronomers keep their desks. There are notebooks with squared paper. There are pens that feel good to hold. There is a small plant near a window that leans toward the light. There is a calendar with proposal deadlines, circled thoughtfully, not fearfully. There are emails, many of them, but most are short and kind, with greetings and sign-offs that read like the exchange of tea in a hallway. Collaboration is a steady hum. Multi-author documents fill in details layer by layer, with comments that are constructive and polite. The final draft has an acknowledgement section that thanks the staff who run the telescopes at night, the teams who built the instruments, the agencies that funded the work, and the families who tolerated the odd hours. It is all part of a quiet ecosystem. Imagine yourself again on that plateau. Looking up, the early parts of the night have passed. The Milky Way arches like a soft river of milk. You can trace it from horizon to horizon. Constellations shift slowly. Satellites slide past without sound. Tiny, moving stars. Somewhere, a meteor leaves a short, bright line. The air is cool on your skin, and your breath fogs slightly. You feel grounded and tiny, but not in a way that makes you small. You are part of the calm. There is also the gentle fact that the universe is not static on human timescales only. Some changes are visible for those who look patiently. Variable stars pulse. Nebulae expand. Comet tails grow and shrink. Ice and rock sublimates in sunlight and refreezes in shade. over decades, we can see supernova remnants creep outward. Instruments come and go. Each has a retirement, a passing into memory, while the data stays. The data is ageless in a practical sense, because it can be reanalyzed with new ideas, yielding fresh stories from old light. When the morning approaches, the observations end with closing routines, just as they began with opening ones. The dome shutters roll back into place. The telescope is parked in a safe position. The instruments are warmed or cooled to their standby states. The files are copied to long-term storage. A report is written. A light is turned off with a soft click. The quiet returns to its baseline. The gentle rhythm continues, ready for the next night, the next story. As the sky begins to pale, the sun hints at its return. The stars fade slowly, not because they are gone, but because the nearer light washes their whisper away. You take one more look, knowing that in the evening they will return as faithful as ever. You gather your things, which is to say, you gather your attention back into your body. Your breath remains slow and even. Your mind holds the smoothness of vastness without any need to fill in details. You are safe and quiet. If you find yourself awake a little longer, you can imagine again the cosmic edge. Not a boundary, but a horizon painted by time. You can see the maps, the catalogs, the rituals of calibration and careful logging. You can feel the steady companionship of standards and constants. You can picture the slow rotations and the stately arcs of lenses and the smoothing of maps that turn noisy data into gentle landscapes. You can remember that everything we see is composed, measured, and cared for by people who like to do things carefully, who prefer quiet success over loud triumph. You can rest in that preference and let your own preferences drift into alignment with it. The tale we told tonight was not meant to resolve or to dazzle. It was meant to be a pillow of facts, a blanket of context, a soft lamp of insight. The universe is immense, and its edges are only the limits of what light has had time to say. The rest will be said in its time, in its voice, which is very slow and very gentle. You do not need to listen to all of it. You are allowed to sleep. As you settle deeper, know that we will be here again with another calm journey when you want it. If this gentle drift helped you relax, a like and a subscribe help us keep the lights softly glowing and the videos coming at this steady pace. For now, let your eyes grow heavy, let your breath smooth, and let the quiet edge of the universe become the quiet edge of sleep. Good night.